Good morning to all. Welcome to the Sigma e-learning platform, the smart way to excellence. The topic we'll discuss today is the polynomials, chapter 2 of class 10 in state syllabus of Andhra Pradesh. A polynomial is a mathematical expression which consists of variables, coefficients that involve the only operations of addition, subtraction, multiplication, and division. Here we can conclude here what is the polynomial, what is not the polynomial. By observing the expressions, we can conclude whether it is a polynomial or not a polynomial. For example, see here the expression 5x square plus 2y minus 7. In this expression, we have to observe the coefficient, exponent, variable, basic mathematical operation, and constant. See, the x and y are the variables here. Why? Because simply the variable is which doesn't have any fixed value. For example, we can imagine x value as a 1, 2, 3, 4, anything. Here also y can also imagined as a 1, 2, 3, 4. So we can conclude x and y as the variables. So this is all about variables. Then come to the coefficient. Here 5 and 2 are the coefficient of x and y respectively. And constant number is the number, a fixed number, which is the last term of the any polynomial. Here in this expression, the 7 is the constant, and plus and minus are the, we know that they are basic mathematical operations. Then come to the what is not polynomial. Any mathematical expression, division by variable, negative exponent, decimal exponent, any infinite number of times, we can conclude with these 5 conditions we cannot say any mathematical expression as a polynomial. For example, see here 3x power minus 2 plus 4. Here the exponent is the minus number. So according to this conclusion, negative exponent cannot be the polynomial. So this is not the polynomial. Then come to the root 7. Then come to the 5 power x. 5 power x is not the polynomial because a variable cannot be the power of the any fixed number. Then come to the, see, another thing, 7x power minus 3 minus 2x. Here also the exponent is the negative number. So we can say that this is also not the polynomial. Here come to this expression. So the variable has the negative exponent, means negative power. So we can say that this is also not the polynomial. See, next case, what is the polynomial? All these expressions have the similarity with this given expression, but any of the polynomial expression doesn't have the these 5 operations. So we can conclude this all set is a polynomial, this all set is the not the polynomial. Are you clear now? I think the degree of the polynomial. What is the degree of the polynomial? Any given polynomial, simply the degree of the any given polynomial is the highest power of the variable. For example, highest power of the any polynomial expression is called the degree. In this expression, what is the highest power of the x? 1. So the degree is the 1. In this expression, what is the highest power of the variable? 2. So the degree is the 2. In this expression, what is the highest degree of x variable? So 3. So degree is the 3. Then come to the two variable polynomial. For example, see this expression. Here the polynomial has two variables, variable x, variable y. So in this kind of expression, we can conclude the degree of the polynomial as the highest sum of the two variables. For example, this is the polynomial in three variable 3xy minus 2. See, what is the power of x here? 1. So what is the power of y here? 1. 1 plus 1. So the degree is the 2. The sum of the powers of variables is 2 plus 2. So here is the degree is the 4. So because of this reason, in this expression I told the degree is the 4. Why? Because the sum of the variables 2 and 2. So 2 plus 2, 4. 4 is the highest degree of the this entire polynomial. So I think the degree of the polynomial concept also clear now. See, note here, only number also we can convert thing. The polynomial has algebraic expression as well as the graphical expression. Means every polynomial has, with every polynomial one can do mathematical operation like addition, subtraction, multiplication, division, as well as every polynomial can be expressed as a graphical representation. Means any polynomial will have the particular shape, whether it is u shape or whether it is a straight line in graph paper. According to degree, each polynomial with a different degree have different shape. For example, a polynomial with degree 1 is a linear, means the straight line in the graph. General expression of polynomial with their degree. For example, see here the polynomial. It's a general expression. P of x is ax plus b is the general expression of the linear polynomial. Any polynomial with degree 1 is called a linear polynomial. Any polynomial with degree 2 is a quadratic polynomial. Any polynomial with degree 3 is a cubic polynomial. Degree 4 quadratic polynomial. Degree 5 quintic polynomial. See here, this polynomial has a degree 1. So we can conclude it's a linear polynomial. This polynomial has degree 2. So we can conclude it as a quadratic polynomial. This polynomial has degree 3. So we can conclude it as a cubic polynomial. In this way, only fixed number has degree 0. We have already discussed in previous slide. General expression of the any polynomial. For example, P of x is ax plus b. P of x is ax square plus bx plus c. P of x is ax cubed plus bx square plus cx plus d. See, observe here, each polynomial, these all are the basic representation, so the or general expression of the linear, quadratic, cubic polynomials. So this all three are the general expression of linear, quadratic, cubic polynomials with their respective degree. For example, we have already discussed that linear polynomial has degree 1. See here, quadratic polynomial has degree 2, cubic polynomial has degree 3. This is the general expression, this is the degree, this is the example. For example, if P of x is the polynomial in x, if k is any real number, then the value obtained by replacing x by k in P of x is called value of P of x at x equal to k. Simply, any polynomial, by substituting in particular value, we can get the some value. That is called the value of the polynomial or particular point. For example, see here the polynomial is x plus 8. At x equal to 1, the polynomial became 1 plus 8 equal to 9. Simply means at x equal to means we are substituting 1 at x equal to 1 means we are substituting 1 in the place of x. So 1 plus 8 it will become the 9. In this way, here the value of the polynomial at x equal to 1 is 9. So this is the meaning of this entire definition, the 0.4 definition. Okay, see, for example, see the polynomial here, P of x equal to x square minus 3x minus 4 at x equal to 1. Simply we have to substitute the x value as minus 1 in the given polynomial. So same thing has happened here. We have to substitute minus 1 in the place of x square. So it will become minus 1 square. Minus is the same as, in the x place we have to substitute minus 1. So minus 3 into minus 1. So minus 4 is the constant term. So we have to make it a ditto. So by solving the entire formation, we'll get the 0. So this is the value of polynomial 0 at point x equal to minus 1. Simply we are substituting a particular value of x in the polynomial to simplify the given polynomial. So this expression is called the value, will get the value, the 0 of the polynomial. Means by substituting particular value in the given polynomial, if the polynomial becomes 0, then we call it as the polynomial, that number is the 0 of the polynomial. For example, by substituting minus 1 in the polynomial, we got the 0. So minus 1 is the 0 of the given polynomial. This is the major conclusion we have to draw from this example. I am telling the 0 of the any polynomial is by substituting particular constant value in the given polynomial, the polynomial became 0. In this case, by substituting minus 1 in the polynomial, the entire polynomial became 0. So we can conclude that minus 1 is the 0 of the polynomial. Okay, are you clear now? In the same way, by substituting 4 in the place of x in the given polynomial, this polynomial became also became 0. So we can say -1 and 4 also the zeros of the polynomial. Why? Because by substituting -1 as well as 4, the entire expression became the 0. So we can conclude -1 and 4 as the zeros of the any polynomial given polynomial expression. The graphical expression of the polynomial based on their degree. We have learned already that a polynomial with degree 1 is called a linear polynomial. For example, any linear polynomial, if we express this polynomial in graphical form in graph book, we can we can get the result as a straight line. For example, see here, this is the one linear polynomial. By expressing that given polynomial in a graphical form, we got the linear form. This is the quadratic equation. So see, for example, see here, what is the polynomial? This is the quadratic polynomial. Why? Because highest degree is the 2. So by expressing this quadratic polynomial in graphical form, we got the U shape with degree 2. Then come to this is the cubic polynomial. So by expressing the cubic polynomial, any cubic polynomial in the graphical form, we got this kind of shape. It can be this, it can be this, it can be this, but the similarity of the shape is the same. For example, for any quadratic polynomial, the shape can be this, like inverted U shape. It can be this, means simply it always the U shape. We have to remember that any linear polynomial with degree 1, any polynomial, it's always give the graphically as a straight line. For example, see here, y equal to 2x plus 3. We know that this is the linear polynomial. Why? Because it has the degree 1 only. So by expressing this polynomial in graphical form, we got the straight line only, any polynomial. So I think the shape of the polynomial clear now. Then come to the geometrical meaning of zeros of the polynomial. What is the meaning of a particular polynomial has a certain set of polynomial zeros of the polynomial? What is the physical meaning? We can discuss now. Before that, we have to know that any particular graph cutting the x-axis always has y coordinate as a 0. For example, here in this graph, this U-shape cut the x-axis at -1 0 4 0. Here in this straight line cutting the x-axis at -3/2 0. Here any point on the graph which cut the x-axis, y coordinate always the 0. For example, -1 0 -4 0. What is the value of y coordinate here? 0. What is the value of y coordinates here? 0. Means any point, whether it is 3 0 4 0 5 0 10 0 -5 0 -6 0, if the y coordinate is 0, then the particular point must be on the x-axis. So here y coordinate is 0, here y coordinate is 0. So these 2 points fall on the x-axis. We have to remember first thing. The second thing is, for example, if a polynomial has 3 zeros of polynomial, then it will cut the x-axis at 3 places. For example, in this graphical expression, this curve crossed the x-axis at 3 points, here, here, here. So at 3 points, this graphical expression cutting the x-axis. So this polynomial graphical expression have the 3 zeros of the polynomial. This is clear, I think. Example, if the polynomial set has 6 zeros, then it will cut the x-axis at 6 places. Y equal to 2x plus 3. This is the linear polynomial. So we got the straight line. So one conclusion we draw. At the same time, it has the 0 of the polynomial at -3/2. Means by substituting the -3/2 in this format, we'll get the 0. So -3/2 is the 0 of the polynomial. We know that if the y coordinate of the any point on graph paper, we can say that it is on the x-axis. So here minus 3 by 2 is the 0 of the polynomial. See, solve this expression, conclude that x equal to minus 3 by 2. So x coordinate is minus 3 by 2. So y coordinate is always 0 when it cut the x-axis. So at particular point minus minus 3 by 2 0, this polynomial cutting the x-axis. In this expression at minus 3 by 2, the polynomial became the 0. So minus 3 by 2 is the 0 of the polynomial. See here, for quadratic polynomial, it has cutting x-axis at two particular points. So minus 1 and 4 are the zeros of the polynomial. If you want to check out, please solve this expression. You will find out that it has two zeros of polynomial, one at minus 1, the second one at 4. Why it is y coordinate 0, here also y coordinate 0? Because these 2 points lying on the x-axis. So any point which lies on the x-axis, y coordinates always 0. Any point which cut the x-axis, y coordinates always 0. See here, 2 0, 5 0, minus 2 0. The common thing in all these three terms is y coordinate is 0. So this all 3 points are lying on the x-axis. In the same way, if any coordinates lying on the y-axis, x coordinates always 0. Observe the pattern here, 0 2 0 3. So x coordinates are 0 0 0. So when the x coordinates are 0, these 3 points lying on the y-axis. The same thing I have explained here. X square plus bx plus c is the basic expression of quadratic equation. Based on the value of x, we can conclude whether it is a U-shaped curve or inverted U-shaped curve. For example, in this expression of a polynomial, if the a value is more than 0, then the shape we will express is we will get the U-shaped quadratic polynomial. If the value of a is less than 0, then we will get the reverse U-shaped quadratic polynomial. See, for example, we can conclude here. See here, this is the ax square plus bx from C. Just compare this x square minus 3x minus 4 with this form ax square plus bxc. For example, what is the value of a? What is the value of a here? A value 1, b value minus 3, c value 4. Just I'm comparing ax square plus bx plus c with x square minus 3x minus 4. Just I'm comparing this general expression of quadratic equation and the real polynomial. I'm comparing. By comparing, I can conclude value of a is 1, value of b is minus 3, value of c is the 4. Expression, what is the value here? Value of a here? A. Value of a is 1. 1 is whether it is more than 0 or less than 0. So it's a more than 0. So I got the shape U-shaped curve I got. Why? Because the value is more than 0 here. Means simply by comparing this and this, we can conclude value of a is 1. So 1 is the more than a 0. So I got the U-shaped curve. For example, if the polynomial is minus 4x square plus 3x plus 6, just imagine if the polynomial is minus 4x square minus 3x minus 4. What is the value of 4 here? By comparing this form, minus 4x square means the value of a is minus 4. So the value is minus 4. So we get the graph in reverse U-shaped form. I think, see here the observation. This graph cutting the x-axis minus 2 0 0 0 2 0. So what is the common observation here? Y coordinate is always 0. We already discussed that if the y coordinate is 0, this entire points are laid on the x-axis. So polynomial p of x of degree n, the graph of y equal to p of x intersect the x-axis at most n point. Therefore, a polynomial p of x of the degree n has the most n zeros. Simply means if any polynomial has 10 zeros of polynomial, this graphical representation of polynomial cut the x-axis at 10 points. If any polynomial has the 3 zeros of polynomial, at particular in graphical representation, that particular polynomial cut the x-axis at 3 points. If it has 4 zeros of polynomial, it cut the 4 points. For example, in this graphical expression of the polynomial, we can conclude that this given polynomial has 3 zeros of polynomial. So this graph cutting the x-axis at 3 points, here, 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 at 3 particular points, the graph cutting the x-axis. So we can conclude this graph has 3 zeros of the polynomial. The same thing expressed in this remark. The relationship between the zeros of the any polynomial and the coefficients of the polynomial. For example, if any particular polynomial has the 2 zeros of polynomial, for example, alpha and beta is the any 2 zeros of the polynomial in quadratic polynomial, we can say that alpha plus beta equal to minus b by a, alpha into beta equal to c by a. What I am explaining here is ax square plus bx plus c is the quadratic equation. It has 2 zeros of polynomial. I am imagining alpha and beta are the 2 zeros of the polynomial. The sum of these 2 zeros of polynomial is always minus b by a. The product of this two polynomials is c by a. Topic will be cleared when you solve the problems. If the polynomial is a cubic polynomial, it means it has 3 roots or 3 zeros of polynomial. For example, any quadratic equation has the cubic polynomial has 3 zeros of polynomial or 3 roots. Let's imagine alpha, beta, gamma are the 3 roots of the cubic polynomial. Then we can conclude that alpha plus beta plus gamma equal to minus b by a, alpha beta plus beta gamma plus gamma alpha is equal to c by a, alpha beta gamma equal to minus d by a. So here also this thing also it can be explained clearly while we solving the exercises. Thank you all.